For this next problem, we're going to continue on this idea of titrations and sort of like these what-if type problems. There's all sorts of little catches in these types of problems. So first one, calculate the pH of 0.10 molarity NaOH that is added, so that's the stuff you're adding to the titration, added to 50 mils of 0.10 molarity acetic acid. So this is what's in the beaker, 50 mils of 0.1 molarity acetic acid. So I know the volume and I know the molarity of this substance. I am slowly adding through the burette 0.1 molarity of NaOH, some volume. Okay, let's look at specifically how much we're adding. We are adding 45 mils. 45 mils of NaOH is added at this point. Now, some background information is the back of the book. The Ka value for acetic acid is, of course, 1.8 times 10 to the negative 5. We keep doing that one over and over again. Let's take a look and see how this would play out. And this is going to give us another little wrinkle to these types of problems. And we mentioned it a long time ago, but we're going to see it now. I'm going to do this the lazy way, and I'm going to say HA. And I'm running this as a titration. So I'm going to list it off like that. And this is a one-way direction going on here. And then it's going to create some, again, I'm going to be lazy and just put in the A minus and then H2O. So this is a acid-base type reaction, acid, base, and then you get a salt, sodium acetate, and then water. Now, based upon having two different things that we're adding, we need to do this problem a little differently. We're going to use moles. So use moles for titrations because the volume is going to change based upon, or the total volume is going to change based upon how much I add, and therefore that is going to affect the concentration of these two things. So it's initially a reaction. So starting off with the acetic acid, one of the things that may be helpful for these kind of problems is sometimes I didn't leave myself a lot of room, is I'll list specifically the information I have above the things that I'm talking about. I know the concentration of this. I know I have 50 mils of this. And I also know I'm adding 45 mils of this. My question is, what is the pH? And the pH will come out from here. I'm not going to write it right here. I'll find whatever. pH. So I'm trying to figure out what the pH of this is. Okay, let's start adding and putting stuff in here that I know that maybe I can figure this out. For the acetic acid, because I have these two things, I can write the moles. I just multiply those two guys together, and you get 5.0 times 10 to negative 3. And I'm going to write this in. Those are moles. For the OH concentration, putting that in, I'm going to go ahead and throw that in now. Initially, once I've added these two guys in, I've added this amount. And that's, again, multiplying the 45 mils times its concentration. I should have wrote that up here. 0.1 molar concentration. So I'm having that in here. Now, of course, starting off here, I don't have any of this, and water I don't really care about. Having this, OH is a strong base. It is going to go to completion and take whoever it can with it. So it does react completely. And of course, at the end of the reaction, it's just gone. I've done with that. Now it's going to react equally with the acid. So there it is. That amount is gone. And what I'm left with remaining is 5.0 times 10 to the negative 4 moles. Now, of course, whatever it took away, it's going to add that exact same amount over to the other side. And -3, I don't think I put -3 over here. So there it is, and now for my final amount, it's right there. Okay, now my total volume is the 45 mils of the NaOH and the 50 mils of the acetic acid. Add those two volumes up, divide by 95 mils. We'll get some new concentrations for that. So let's go ahead and take a look and see what that would be. So new concentrations. For the acetic acid, that is going to be this moles, so 5.0 times 10 to -4 moles, divided by the total volume, which is going to be going to write it as far as liters go, 0.095 liters, I don't know why I'm putting brackets on that, is equal to, I'll go ahead and write it this way. I never really do, but it's in my notes, so I'm just going to leave it. 0.0053 molarity, and that is for the acetic acid. Write it again, HA. For the A minus, the sodium acetate, same idea. I'm going to take this 4.5 to -3 divided by the same total volume, and that's going to give me 0.0474 molarity A minus. Okay, so I have these two values. This is fantastic. I think I'm almost done. I want to know the pH. If we can recall, looking at what Ka represents, looking at, starting off with the acid, let's actually slow down here a second and just kind of back up. So we can just add the step in here. Normally, after this reaction is done, it's 100% done. So the idea is you still have some acid, some amount, and it's going to do its thing, and it's going to reach an equilibrium that looks kind of like that. We are going to put this together just like we did in chapter 15 all the way back and say Ka, maybe this is chapter 16, and say that in this very specific example, we are going to have H plus and A minus over HA, and we can set this up and solve for the H plus, or we can really use the tools that we've already developed, which is the Henderson-Hasselbalch equation, which is much easier. So we're going to take a look at that, rewrite it. And again, either one of these methods will work fine. I'm not going to show you the other because we've done it a lot, and this just happens to be easier. I want to solve for pH. That's exactly what it's asking for. So putting these parts in here, we'll say negative log of the Ka, and I wrote that down earlier, plus the log of these two values that we do now have, and we just got to make sure you put the base over the acid. And if we run this through our calculator, we should get 5.69. Fantastic. That's the answer. Done. Okay, let's do one more, and I'm not going to get all the way through this, but I want to get it set up. So we'll go into the next video with this problem. Problem starts with calculate pH, so very similar problem, at the equivalence point in a titration of 50 mils of 0.1 molarity. It is acetic acid. I'm just going to, well, I better write that down just to be specific. acetic acid with an equal molarity NaOH. So this will be our setup here. I'll go ahead and just write a couple things down for rice, and now I'll get lazy. Again, this is a titration. This is not an equilibrium equation, so we're not going to think of it that way. It goes all the way to completion. It's a titration. So you have a strong base reacting with the weak acid. All right, we'll fill the rest of this in just a moment. Well, maybe not, in the next lecture.